how do we know that this distribution landed in this nice bell-shaped curve? Does that always happen? How do we know if that's going to happen or not? Dun, dun. Dun, 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 dun. How did the quiz go? Have you done the quiz yet?
Yeah.
What was the first question on the quiz?
What happens when the number closes?
Wow, you sound totally weird.
Yeah.
People haven't done the quiz yet. I don't know, but I should. There's one question that's like if the number of trials increases.
Okay, you're getting a lot of reverb on your mic. But I like that. Yeah, it's bouncing back and forth in your speech.
I don't know why that's happening. I'm sorry.
That's okay. Just two things. One, that's good, because I really didn't want everyone to understand your answer, because I want them to read it and make sure they look it up and figure it out. So that's great. And two, stop talking. It hurts. Sorry.
Sorry.
That's a horrible. No, that's a horrible sound. It's like a Dalek. So yeah, I'm not sure why that's happening. But from what I could pick up in that, you're right, which is awesome. But the rest of you do be careful about that first question. Make sure you're reading your textbook about trials and curves. Fair? So I wanted to kind of throw that at you, because it is a big assumption, because it doesn't have to look like this. But we know it looks like that under certain conditions. So knowing what those conditions are going to be really important later, because we're going to use some of the normal distribution tools, and we're going to have to know when do those tools apply. And we're going to have to test to see if they apply. So knowing that's going to go a long way to helping in chapter 8 especially. Okay, questions about these two problems or anything else from 6.2?
When I enter the binom CDF, what you have there into my assignment, it says it's wrong.
Oh, yeah?
Unless I'm doing my math wrong.
Let's look at what it's supposed to be. What question was that, 12?
Yeah.
What did you get as a probability?
0.98937.
Anybody else want to put that in and see what they get? Because that seems awfully high. But it should be awfully high.
Yeah, I think that calculation is right. But I think the question was asking at least as many days as that unusual value. And so we would have to do 1 minus the CDF of 21 or below if we're trying to get 22.
Right. So 22 and below would be an at most 22.
Yeah.
Okay?
Yeah, that's what I was looking at.
At least 22 means 22, 23, 24, 25, 26, and all the way up, right? So, and I should have caught that, and I didn't. So thank you.
Yeah.
Andrew.
That wasn't quite right. I was trying to figure out
Yeah.
what.
At least, remember, at least gives us the lower bound, right? So that means we want that and up. So that number that you got, that 0.9893, what do we have to do with that to get the up portion?
Minus it from 1.
Subtract it from 1.
Subtract.
It's okay. Pet peeve.
Except I think if we want to include that 22, we'd have to subtract the CDF with
21.
21 or less instead of 22 or less.
Oh, you're right. Look at you go today. Because we want to include the 22, right? So we just subtracted off that 22. So we would want to subtract off 21 and down so we could include the 22. That might benefit from, wow, that was cool. Didn't want to do that. That might benefit from us chatting about it a little more. So let's redraw our diagram here. Unless everybody's like, no, we're happy with that. So I'm gonna make myself some space here. So Jesse, this gets back to your being really careful how we read, right? And really what I should have done and didn't was,
Where did it all go?
where did what go?
Sorry, that was on my calculator. I'm gonna mute myself.
This is that other thing that I was telling you about, Michelle, though. When we did the accumulative of it down and then you minus it from 1 to get that answer.
Subtract it.
Subtract it.
It's a verb. Minus is the verb. The noun. Sorry. So what I should have done is written that down so we could look at it. So, whoop, need my pencil working. So we've got our 0 through 47, and we're going to kind of zoom in here. We had, I forgot where the low was. It was about 5-ish, right? Our median was at 15, and at 21.4, I think it was our 2 standard deviations, and that was somewhere like 11, I think, ish. And that's at 15. So we found that the first unusual value was 21. And we want at least, that's the key language there that we have to be more careful about, at least as many times as our answer in part B. So at least this 22. So that should be 22. I should eat breakfast before I do this. So that's our 22. So we want to be at least 22, which means we need 22, we need 23, we need 24, and so on all the way up to 47, right? So we want this range. But just like the tools in chapter 7 that we're going to talk about, our CDF tool doesn't do and upward, it does and downward, right? So we're not going to directly find this probability. And notice in preparation for 7, notice, we kind of highlight this area here. When we find the probability of being in that range, we are actually finding the physical area under that curve. This curve is a special type of curve. Its area underneath that curve, if we, made a bunch of little boxes in there and tried to, calculate the area between the baseline here and this curve, even though it goes on forever and ever and ever, gets really super thin forever and ever and ever, that area under that curve is not only finite, it's equal to 1, because it is the sum of all our probabilities. And what do we know all our probabilities add up to? They add up to 1. So we're actually not only finding a probability, we're actually finding a physical area under that curve. So you'll start seeing that language a lot more often. Sometimes they'll say, find the probability, find the proportion, and sometimes they'll just say, find the area. Like, how do I find the area? I know how to find the probability and the proportion, but how do I find the area? Same thing. Fair? So, nice chat about that before it pops up. So if we want that area, since our tool only does places and down, we're going to have to go one number down, 21, and all the way down. So we're going to have to find this area. Now notice here, and this is going to be important when we start talking about chapter 7, there's a gap in there, right? There's this gap here. Because we're talking about individual numbers of successes, there's nothing in between that 21 and 22. So that gap is empty. Fair? If we were to draw this curve out, or this distribution out really accurately, we'd actually have a bunch of little blocks, each of different heights, at each one of the whole numbers, 0, 1, 2, 3, with nothing in between. We draw it as a smooth curve because it's convenient at this point. But because it's discrete, we have, oops, well, that didn't work out as nicely as I wanted to. There is empty space, essentially, in between, and that's okay, because it happens in those discrete chunks. Now, once we get into chapter 7 and we start talking about a continuous variable, there's not going to be that empty space in between. Right? So what's going to happen is that 21 and 22, they're going to kind of meld together. And we won't be doing this, well, are we talking about the one less or the one more? Because they'll essentially be the same value. They'll come together on each other. So be careful. This idea of having to look a full whole number down and a full whole number up is specific to this being a discrete distribution. Fair? So be careful about that. When we get into chapter 7 and we're looking at continuous distributions, we stop doing that. So I'll show you that when we get into talking about chapter 7, but be careful about that.
In this particular question, so I understand everything you're talking about, except for when you get to so the way it's worded, find the probability of getting your lunch at least as many times as your answer in part B, how do you know not to use 22? How do you know to use 21 instead?
Here's a nice way to do it. What do we want? What numbers do we want? Do a big box for the numbers we want. We want the probability of, well, certainly 47, right? And 46 and 45 and all the 40s, right? Right? And we want all the 30s, so 30, 31, 35, 36, all the 30s, right? I'm not going to write them all, but we want all the 30s. And we want the 20s. We want 29, we want 28, we want 26, we want 25, 27, 24. We want 23, right? Do we want the 22? At least 22, right? So we want the smallest number in the bag we end up with to be that 22. Fair? This bag contains every number that is at least 22. Fair? So to do that, what are we going to have to take away from this curve? So if that's what we want, what are we going to take away? What are we going to minus? What are we going to
except for
subtract?
22.
We're going to subtract 0, 1, 2, all the way up to 21. Fair?
Yeah, that makes sense.
So 1 minus the bag that goes from 0 to 21 is going to give us the bag that contains 22 and up. Fair?
Yes.
Now, and the reason why that stops being as much of an issue when we start talking about continuous variables, is we talk about continuous instead of discrete, 21 happens, but also 21.1 happens, and 21.2 happens, and 21.3 happens, right? So this starts pushing all the way up to and against that 22. But because there's nothing in between the 21 and the 22, we don't want to add up the kind of mythical pretend stuff in that gap. We want to make sure we're respecting that that gap is truly empty. Michelle, is that better?
Yes.
It is.
That makes sense.
It is surprising how helpful drawing those bags can be.
Yeah.
You know, so when in doubt, make that list. You don't have to list out all this stuff, but what do I want? Well, I want 22, 23, 24, and on. So I want to get rid of the rest of them. So what am I getting rid of? What am I subtracting? The 21 and below. Cool. Okay, what else you got?
So if that were, say, instead of an at least problem and it was at most, is that where you still can just use the CDF and then you don't have to subtract it from 1?
Right.
Because then you're getting the, okay.
And it could also things like, probability of forgetting your lunch more than or equal to the times in your other answer. That would be the up. If it said less than or equal to, I'm the down. And that's, they'll try to stay with greater than or equal to, less than or equal to, more than or equal to, at most, and at least. They'll try to stick with that language. But as we were talking about before, people will often express that in whatever crazy way they want to express that. And we've got to be kind of able to adapt to that in practice. Well, again, we're not going to go crazy with that. But in practice, we want to be very fluid with that. It doesn't matter whether they say, least, most, it doesn't matter what words they use. The context tells us, I want this group as opposed to that group. Fair? Now, again, particularly with that language, we're not going to go too crazy with trying to, say it in weird ways. We'll stick with the kind of couple of ways that we have so far. But you go out there in the world and people will express things however they want to. So getting used to that's going to be important. Yes, ma'am.
I just wanted to check. I just logged out again. Is it back? Is it
Nope.
good?
You're good. You're totally good. Sorry that was an issue. I hope I didn't make you feel bad, but that was.
No,
really-
I also was hoping I wasn't like I didn't know if you wanted me to answer the question. I was
Yeah.
like, I don't know if I should share this answer right.
But yep, it's all good now. Thank you. Okay. Anything else about 6162?
Yeah, I've been having a problem. I've been working on I think it's 6.2. Yeah, the 6.2 homework for quite a while, and I keep on getting stuck on quite a few questions. I think the biggest part that I'm having a hard time understanding is finding the at least probabilities of answers. So, is there a way that you can kind of clarify on that so I can find a way to make it a little bit easier?
Did any of this last part that we're talking about with the boxes help?
It did kind of help,
Yeah.
but I don't know. Math in general is not an easy subject for me, so
Yeah.
I'm getting most of it right. Like right now, I'm on question 7 of the 6.2 homework, and I got all of the answers right except for the top one.
Yeah.
And I don't know where I'm going wrong because I went through and did everything that you just said and explained, and I have no idea what I'm doing wrong. So
I like that you pushed that onto me.
sorry.
That's good. No, that's good. We don't want to personalize this, right? So one of the big things to do is practice. So I'm trying to look for one that's nice and focused on that.
If you
But I
need,
might just grab 7 if you
I'm
want.
willing to work with you after class and go through some of that stuff, Lavina.
That would be fantastic because I have been
Yeah.
working on it for days now. I went back through the videos and everything from last week, and I still don't understand what I'm doing wrong.
Yeah, we could just log back in after
Grab that.
class and like go through some of that and see what we could do.
Okay, sounds good. I just want to make sure I'm getting the homework done and I'm understanding it. So
Yeah, because it's due today. So yeah.
So let me grab one of those and kind of let you guys play with it for a little bit and see what you guys get. I originally wasn't planning on spending this much time talking about, I was going to see what you guys, want to talk about, but it seems like we're doing some good work today, reviewing some of this stuff and making sure we're comfortable. So, and our schedule can handle it. So I'm happy to sticking with 6.2 today. As long as you guys read chapter 7, well, look it over. It'll help things go nicer. So, given this question as it's stated, try to decide how you'd approach it. What would you write out? What would you draw out? Oftentimes, I know I stress the drawing the diagram, the drawing the little bags. It can be surprisingly helpful. So if you're not trying to draw some diagram, if you're like, well, I'm not sure what to draw, that's okay. Figure out what to, visualize. Sometimes focusing on that part can be really helpful. So if you're not giving yourself some visualization, it can be super, super helpful to do so. So that's one of the big things I recommend. But I'll give you a quiet minute or two to play with this. Some of you are squinting. I'm better if I make that bigger. If anything does come up too small on this, let me know. I can scale stuff. Again, right now, these are all binomial type questions, but once the problems get kind of integrated together, having that first step of what kind of problem is this? It's a binomial problem. Okay, that sends us down a path. That path will require a number of trials, a probability of success, and a probability of failure. We might not need Q, but it's to have it. It is always a little bit fun. Well, I don't know if fun's the right word, but it's common for people to come up and be like, I've been working on this problem for 2 hours and I can't find P. And I'll look at the problem and go, that's a mean question, or that's a question, the distribution of means, not a binomial. Not a binomial won't have a P. So if you're trying to force a non-binomial distribution question into this model, and it's not a binomial distribution question, you won't have the pieces. You'll start doing crazy weird things to try to make them. So that step of deciding what these NPQs are is important. And deciding what kind of problem it is an important step. So 3 items chosen at random. Probability of it being successfully defective, it's always weird, but a yes. So the probability of that yes, 0.06. And Lavina, if that's how you pronounce that, probably Q, you're 0.94. Good. Okay. And you were saying, the general idea is making sense, so that's good. But we want to get to, okay, that's our 1. 2, is this a CDF question or a PDF question? So is it a single value or is it an interval? Single or an interval. So as soon as we see anything other than what's the probability that it's exactly 1 or exactly 2 or just 3, any at least at most are all expressing intervals. So they're all CDF questions. So the nice thing about this is we're only having 3 pieces or 3 trials. So how many possible outcomes are there when there are 3 trials? How
9?
many possible things could happen?
9? Wait.
Well, how many could be defective?
8. Well, there's 8 possible.
You're thinking 8 possible distributions of the successes and failures.
Yes.
But of the 3, how many could be defective?
0, 1, 2, or 3.
0 could be defective. 1 could be defective. 2 could be defective. Or 3 could be defective. Those are your only choices. Fair? Camilla, you're thinking of the 3, how many ways could we distribute yeses and nos? And that is 8, you're right. But this was a different question.
Okay.
Fair? So when we're drawing out our kind of our diagram for what could happen, we could get a 1, a 2, a 3, or a 0. We want to know the probability that at least 1 will have a defect. So at least, the trouble, I think, one of the reasons that people have some trouble with at least and at most is people associate least with less and most with more. And if we say, let me do it this way. Bring less than $10. Bring more than $10. Bring at least $10. Bring at most $10. So these are 4 different statements. And those 4 different statements mean 4 different things. Some of them are close to each other. Some of them are technically the opposites of each other, but they're all different. Fair? And really, I think getting used to being comfortable with the at least, at most, more than, less than, is really being comfortable with differentiating between these 4 phrases. Or I guess they're sentences if I capitalize them. So bringing less than $10. So for each of these, I want to, there's nothing technical about this language, but which ones of these are up and which ones of these are down? I know up and down, I'm meaning on the number line. So if we have a number line here with, $10 there, and we call that way up and that way down arbitrarily. It's actually pretty typical, but some of those languages express things larger than, express an upward trend. Some of them express a downward. Fair? So decide for yourself which ones of those statements are talking about going up the number line and which ones of those statements are talking about going down the number line. And I'll give you a minute to do that. And do come up with firm decisions for yourself. Make confident declarative statements. I think this one is that. I think this one is that. The best thing that could possibly happen to you is you make those declarative statements and you're wrong. Because your brain will go, ouch, I'm going to remember what comes next. If you wishy-washy kind of, I think, I'm not sure, and then hear the answer, your brain will go, all right, I'll maybe remember that, I don't care. So declarative statements. Actually, the very worst thing that could happen is you're right every time, because then you won't learn nothing. So everybody have a solid declarative, I think that each one is this, 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 and this. Okay. Bring less than $10. Is less than $10 up the number line or down the number line?
Down.
Down.
Heard some very firm downs, and I will agree with down.
And not including.
Not included.
Haven't gotten there yet. Don't jump the gun. You're right, but haven't gotten there yet. Because less than $10, and a nice thing to think, and it works with these problems too, what is a number that's less than 10?
9, 8.
9, 8.
9,
Now, what would qualify? Bring less than 10. Well, if I bring $8, is that okay? Yes. If I bring $7, is that okay? Yes. If I bring $13, is that okay? No. Up here, at least 1, okay? Would 0 qualify? Would 1 qualify? Would 2 qualify? Would 3 qualify? Asking that can help you figure out which direction you have to go in. Bring more than $10. Is that up or down?
Up.
I heard 2 ups. And they sounded very declarative. I like that. Jesse gave me the finger. Well, yeah, I'd go up. More than $10? Well, what's more than $10? So 13 is, 14 is, 15 is, $100 is. So up, I'll buy that. Bring at least $10.
And below.
No, that's
I mean,
up.
at least 10 is above.
Notice we start to argue there though, right?
It's at least is 10 or more. At least is
At least gives you a lower bound, right? It
Yeah.
tells you what the bottom is. If you have to bring at least $10, well, you've got to bring, you know, you could bring $10, but you could also bring 15, you could bring 20, bring at least $10. That's the minimum. So that's also going to be an upward. Fair? So here again, at least one. Well, what qualifies? Well, if it goes bad once, then that's at least one. If it goes bad twice, is 2 defective at least 1 defective? Yeah, it's going upward. 0 is the only way for that not to happen. What about bring at most $10?
10 and below.
Down.
Now, why might somebody bring at most $10? I don't know if they're going to go gamble and they're a bad gambler. You can bring at most $10. Okay, I'll bring $10. You'll lose the $10 and that's okay. But don't bring any more than $10. We got bills to pay. Fair? At most $10, at most $10 is a down. Yeah, down that way. Because that most is that upper bound. Fair? Now, direction. Then there's boundary, or let's say inclusion. Included. Now you guys already tried to answer part of that, which is totally cool, but bring at least $10. So some of these include that 10 and some of them don't. I said all of these were different, and so far these two are the same and these two are the same, but they're all different because some of them include the $10 and some of them don't. Fair? So when we say bring less than $10, is bringing $10 okay?
Nope.
No. Because $10 is not less than $10. But if we look at the other down, bring at most $10, is the $10 okay there? Fair? So this at most language is essentially a version of bring less than or equal to $10. Just people don't say less than or equal to in their daily lives. But at most or at least, we do tend to say. Fair? Bring more than $10, is the $10 included, yes or no?
Nope.
You said no. Okay. I'll take a nope. But the other one that's going up, at least $10 is an up, but is the 10 included?
Yes.
Yes. And that whether or not is included or not is important in terms of, you know, if we're going to subtract, do we keep the 10? Do we, do we use the 9 or the 11? You know, whether we have to be on or off that number, whether we're wanting to include or not include that value affects that quite a bit. So the first step to being really comfortable with this at least, at most language is making sure that these distinctions are clear. Lavina, is that helpful? Was that already really clear, or is this a little bit more specific? What do you
That definitely helped me out to try and like understand exactly what I'm looking for. But with the question that I've been working on for a while now, I'm just trying to figure out. So the question says, if 10 students from a special program are randomly selected, what is the probability at least 9 of them are graduated? So do I minus it, or do I enter it into the calculator as a 0 for the, where is it? Give me a second. I gotta find it. As the X value, do I put 9 as the X value, or do I put 0 as the X value? That's, I think, where I'm getting confused as what I use as the
Yes.
X value.
So my first question is going to be, did you draw a diagram?
I tried to.
That's good. That counts. Trying to counts, because then you'll get better and better at it. It's the not trying to that worries me. So and just a number line is enough for a nice diagram. It doesn't have to have a nice curve over it or any of that. So at least 9 of the 10, at least 9, that means we want, at least is we're going upward, right? And we include that endpoint. So at least 9 means 9 and 10, right? 9 and up.
Yes.
Now we know our tool doesn't do and up, right?
Yeah.
Our tool does and down. So we're going to have to get 9 and 10, what are we going to have to take away? I'll ask that question again. To keep 9 and 10, what numbers have to be taken away?
The 8 through 0.
So 8 through 0 have to be taken away. So we want to take away 8 and down. So what are we taking it away from, percentage-wise?
1.
Does that make sense? That 100%? Lavina?
Yeah, I'm just trying to figure out how to put it in the calculator,
Mhm.
though.
I know, I'm getting
You
there, I'm
getting there?
building. Yeah, I'm getting there.
Okay.
Also, you know, I don't know what other folks are struggling with this. This is a very, very common struggle, and that one that we need to get kind of comfortable with. So I'm going the long way, but we'll get there. So 1 minus, I want, 0 through 8, right?
Yes.
So our tool, again, does value and downward, right?
Mm-hmm.
So we're going to subtract 8 and down, right?
Mm-hmm.
That and down is our CDF tool occurring at the 8. So 1 minus that CDF with the NP and the 8.
Okay, that's where I'm messing up.
Now you were saying, do I use the 0? Well, the 0 would just subtract that 0 and would leave 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fair?
Yes. Okay, I think
You
I'm
use
pretty
the
sure I
9.
understand.
And again, I'm trying to, for the people who won't ask questions, I really appreciate questions why, but I want to kind of over-explain it a little bit. The other common thing, though, to do is want to use that 9. The problem is if we use the 9, we're excluding the 9, and we wanted the 9, right?
I think that's where I kept messing up, was that I was using the 9 and didn't understand what I was doing wrong.
Yeah.
Okay, I think I get it now.
Other questions about that? And this gets back to the conversation we kind of had before about, you know, and have had numerous times and will continue to, about being careful when we read problems. I think we were talking about that 50% thing. When we read a problem, we often just look for the numbers and highlight those numbers and put those numbers in. I'm into our tools. And these, one of the reasons these at least and at most questions, at most questions don't tend to be as bad because, but the at least ones tend to be the worst ones. This problem never said the number 8. The problem gave us 9s, it gave us 10s, it gave us probability, it gave us all kinds of things, but it never said 8. So we take the numbers we see and we try to figure out where to put them.
Mm-hmm.
And that doesn't always work, depending on the context of the question. And that's, you know, one of the steps in problem solving, particularly for, you know, good word problem solving, is that making sure we're, you know, reading through the question really well, making sure we're conceptualizing the question really well. Because as soon as you start picking out numbers and putting them in things, what happens is they become sacred. They really do. To the you know, from the brain's perspective, neurologically, as soon as you write down an equation, as soon as you write down a formula and plug anything into it, those things become truly sacred to your brain. It won't want to change them. Fair? So knowing that, we want to do 2 things. One, be aware that, am I clinging too hard to this number? Am I clinging too hard to this formula? And be willing to go, well, maybe I should look at something else, or maybe I should look, you know, be more open to these changing. The other thing is, we want to make sure we read the question, draw some diagrams, make, you know, write it in our own words, all those kind of suggestions we often get about word problems. Do some of those things before we write any formulas down, before we plug anything into anything. We want to make sure that conceptual understanding of what the problem is asking us is strong. Because if we have an okay conceptual understanding of our question, write down a formula that's got wrong stuff in it, and then later try to compete, like, you know, we reread, we get a better understanding for the question as we practice, as we go along and work on this problem. That written formula, that formula that we wrote, plugging in a number, becomes more important. I like that word sacred, it really is how your brain works, but becomes more important than your conceptualization of the problem. Your conceptualization of the problem can way improve, and you won't want to change that formula because you wrote it down. Happens to me too. Does that make sense? So careful about that. Often also just because people don't like, you know, word problems, they want to rush through the word problems. So they'll say, well, maybe if I just grab these numbers and plug them into my tool, that number, it will be right. And you check it, you go, no, it's not right. Okay, so now I got to go back and figure out what I'm actually, you know, supposed to do with this problem. You've got to undo that in your brain. Your brain doesn't like to undo that. Does that make sense? So it's just kind of a word problem approach philosophy spiel there. But, you know, we want to work as much with our brain's natural processes as we can, and backing out of something that you wrote down, your brain's terrible at that. Ever write like a check or something and write down a wrong number? You'll bargain with yourself about how can I, you know, write something else that makes that okay. You know, like you write $10 and it was supposed to be 15. You'll go $10 and 5. No, you can't do that. You gotta write a new one. But oh, you're trying to figure out ways around it. You're bargaining with yourself like crazy. That might have been a bad example, but That makes sense? So be careful about that in word problems. And, you know, I'm Lavina, that's why, you know, it's a struggle to get me to answer the question, what do I put in the calculator? You know, because saying N8, yeah, that might help this question, but it's hard to build on that. So
Okay, well, I understand what I need to do now. I can see
Awesome.
where I was going wrong and not reading the questions right. So your explanation helped out a lot. I actually made myself like a little table on my notes to kind of help with
Good.
later problems.
Well, and I
so-
think your book has a table like this with the less, more, least, most. Mine's got more colors, I think, but other than that,
Yeah, yours was prettier.
yeah. And there's nothing like, you know, going through it and, you know, reading something is very comparatively passive. Taking that active role in making decisions and, you know, fighting for them makes a big difference on how you remember stuff. So that's why we're here. Guys, got anything else?
I have one more question.
Okay, you've got 2 minutes.
When you were talking about the factorials,
Factorials.
my notes are a little, factorials. My notes are a little scattered on it. Was that just part of explaining what we're actually doing in the binomial distributions, and you don't really need to worry about those, or is that completely different?
Yes.
Okay.
The short answer is the calculator tools can handle all of it, no problem. So we don't need to be calculating them by hand. But if we wanted to, you know, we'd be trying to figure out, say, you know, if we were trying to do this problem by hand and didn't want to do this, you know, subtracting those away, we could calculate 9 and 10 individually. Okay? And so if we wanted the probability of x equaling 9 and to add that to the probability of the number of successful trials being 10, we could use those factorial tools. Okay. Well, that big formula. So it'd be, you know, n factorial over x factorial 10 minus 9, n minus x factorial times the probability of success, which I don't know what it was for this problem, 9 times the probability of failure 1 time, and calculate that out. Or if we wanted that individual value, we could find the binomial PDF with 10, p, and 9, and it would give us the same value.
Okay.
Now, some people like doing it by hand. I kind of like doing it by hand. But, and I think philosophically, I like showing, you know, what this tool is actually doing in the background. You know, these were how many successes and failures we had, so that probabilities coming up again and again. And this big factorial combinatorics tool gave us that, you know, how many ways these could be arranged. So we're counting up the right number of them.
What are the variables that go where the 10 and the 9 go? Oh, that sounds like a
n no, not at all. X factorial n minus x quantity factorial times p to the x and q to the n minus x. Essentially, these two will always add up to n, and these two will always add up to n.
Okay.
So if you wanted like 3 successes, you would have, you know, 3 successes and 7 failures. And then 3 successes and 7 failures.
Okay. Thank you.
But if you're like, I hate factorials, I don't want to ever do that. Okay, fine, you can get away with that. But if you go further into probability, or particularly probability, my goodness, but even further into stats or any kind of number theory, factorials will come up more and more and more often. For a lot of
Will you
people, this
ever-
is the first. Go ahead.
Will you ever see it as a CDF, or is it always going to be PDF?
It's the short answer, it's always PDF.
Okay.
This tool is for finding individuals. When they do CDF, they're essentially doing all of those and adding them together.
Got it. Thank
So
you.
the CDF is essentially a sum as X goes from, you know, wherever you start it to N of, you know, 10 factorial. This is probably today overkill, but that's okay. P to the A, Q to the 10 minus, or N minus A. So I'm not 10 for this particular question. So what the CDF does is take that formula and add them together as you go from, you know, either your 9 to 10 or, you know, 6 to 10, whatever your range you're trying to do, adds them up. And technically it adds them up from 0 to A because it adds downward, sorry. But the CDF is just adding this together over and over and over and over again.
Gotcha. Okay.
And yeah, for those of you who aren't going to go do a whole bunch more probability, that's, you know, not necessarily a tool we got to get serious about. But some of you know you're going to go be doing more studying in number theory and probability and stats. And actually, stats careers are lucrative and have a lot of hiring. You know, for decades. I don't know what it is now because I haven't checked in about 5 or 6 years. But for decades, the top 2 jobs of, you know, jobs that had a lot of job growth were statistician and actuary. And the short version of what an actuary is someone that explains statistics to other people. So top 2 jobs were doing statistics and explaining statistics. So there's, you know, work out there. And, you know, for those of you who aren't going directly into statistics, statistics is part of everything that we do. You can't listen to, you know, ads on YouTube without having statistics thrown at you. So, you know, the more you play with them, the more armed you are. So if you go further in statistics or probability, this kind of combinatorics factorial stuff is going to become a big deal. So if you know you're going to kind of head that direction, play with it a bit, just so you're familiar. So when it comes up again, you're like, I remember that. The weird guy with the beard talked about it. Yeah. Okay. Now, tomorrow we're talking about chapter 7, right?
Yes.
Bless you, Andrew.
Yeah.
So go play with this, finish it up. Happy to do this today. I think it was a good conversation for us to have today. Sounds like what you guys needed, and that's great. But tomorrow we'll jump directly into chapter 7. And if you can, you know, look those sections over beforehand, it'll make it go more smoothly for you. So I encourage you to do that.
Matt, can I have 10 seconds or less?
Absolutely. At most 10 seconds.
It'll be probably less. Is there a time that I could talk to you over the phone? Or you could call me, or however you want. I'd like to talk with you over the phone.
Yes. Send me a message and we'll set up a time. Okay. So on My Up in Math says send me a message and we'll set up a time.
Okay, sounds good.
Okay.
I'll send it right now.
Okay.
Thank you.
Well,
All right, have a good day.
you too. Anything anybody else needs? I know we're over time, but I don't have anywhere to go. All right. So actually I do, but anyway, have a wonderful day. If there's anything you need, let me know. And yeah, if you guys want to jump back on, back on after I end it, I do want to end the meeting so the recording will start to process. But if you want to hop back on to go through problems or you work with each other, that's great. And if anything comes up, send me a message. So have a wonderful day.